before the accident, I had been churning or telling the story, which to me was agonizing, very frustrating, with my wife at home. Every day I'd go home to dinner and say, "You can't believe what happened today. The other fight I got into today." And she couldn't believe what was happening. And finally I had some in-laws, my brother and some other in-laws I have, who were eating out the night before the accident. We went through the whole story all over again. They couldn't believe what was happening. So why isn't anything being done? And I just said, I don't know. I can't figure it out. And I went out with a friend of mine to a hamburger place and said the same thing. She told me, said, well, how bad could it be? I said, well, loss of vehicle and catastrophic, loss of the vehicle and loss of crew. She goes, what? I said, she had to remind me of that recently. I said, I don't even remember that conversation after, but it shows that I was speaking about this over and over again. The day would end, I'd go home, brief my friends and relatives, what was happening. They were in disbelief. Okay, let's go to the next one. I'm from Johnson Space Center, and today's September 14th, 2011. I haven't been to NASA headquarters in many years. It's really not officially on business. I was just kind of as a tourist visiting DC earlier. The crew, I put this in and just to remind myself and others that I do it for them, and that we have posters around NASA centers that say, what are you doing for the crew? Speak up, all the different messages. And I was able to meet Mrs. Husband, the wife of the commander, at a book signing, and that was a moving little talk that we had. I was at Johnson Space Center, and I told her I wish I could have done more, and I felt that I had failed. And she had some nice words back to me. Let's go to the next slide. I like these quotes. There's a whole bunch of them, of course, and you probably have them in this building too, but some of them are gone, but this is our former director of engineering. Safety is everyone's job. This is still up with all the pamphlets you can take. Take it to your office and read it. If it's not safe, say so. In fact, I quoted that in one of my emails. It's back of the presentation package there. I was very moved by this traveling display. It's gone now. And I actually met the person who wrote this, that sometimes an individual has a personal touch or participation that could be crucial. In the main, of course, that's not true. But we all affect, when you add it all up, the mission outcome or a crucial decision that's going to be made, what you do about it. And I like this one too. This is put up by the JSC Mission Operations Director. Of course, they plan missions. They're the ones that have mission control and all that, and I really like this one too. To be aware that suddenly and unexpectedly we may find ourselves in a role where our performance has ultimate consequences and has vigilance. And I have many other quotes up here too. Next slide, please. This is just a chronology. I think most people are familiar with it. This is a direct quote out of the Columbia Investigation Report, board report. And basically, that at the front of the orbiter, just behind the main landing gear, there's what they call the bipod attachment. It's an A-frame. And that A-frame are two struts that go down to the external tank. And each of those, at the base of those struts, or the so-called bipods, are about this big, maybe the size of a little bigger than a loaf of bread. And to make them aerodynamically smooth, there's special foam that was constructed over it and sculptured and faired, and put it like this. This ramp here is for aerodynamic reasons to keep the drag down on it, and it's an insulator to keep ice formation from forming on that bipod. It's pretty heavy, dense metal, and the decision was made in return to flight to remove this. There were, I think, as you know, 10 or 11 instances where the shuttle program with photography was able to document that it came off in previous missions before Columbia. And those are the ones where they had enough lighting to see it. There could have been more at night launches, or the photography wasn't good enough. And as you know, we don't ever recover the tank. It's destroyed when it enters the atmosphere, hits the ocean. Also, the crew doesn't always get to see it and photograph it. We tried real hard in Return to Flight to get the crew to photograph the tank as it separates, and there were umbilical cameras and wheel wells and other areas to do photography, including putting a flash in there for night missions. There's flash photography going on. So this, it's hard to believe that this, maybe 2 pounds or so, could cause damage, but you have to imagine that the relative speed between orbiter and the bipod, if it's liberated, is about 500 miles an hour. At the moment, at the 80-second mark, there's still enough atmospheric drag, even though the dynamic pressure is going down, there was still enough drag, and that's what causes the relative motion of the acceleration toward the vehicle. So if it had happened, I don't know, like 100 seconds or so before SRB separation, it might have broken off and just floated back and just ding and bounce off. But at this 80-second mark, there's still enough atmosphere to, and it weighs so little, the drag forces are so great on it, it just accelerates it again. And also remember, the vehicle's in powered flight, so it's accelerating too under all the boosters and engines that are acting on it. So again, it's near this, just behind the landing gear, or the forward landing gear. Seen on Flight Day 2 on a blurry video. We were supposed to get enhancement of it, but we never really did over that weekend. January 16th was a Thursday, I believe. That weekend was Martin Luther King holiday, so we had a Monday holiday. There was well, I'll get to that more about how the debris assessment team formed. And this bipod spun away and hit what we think, or pretty strongly corroborated the left wing, what we call panels 8 and 9. Starting over here, this is panel 1, and this is panel 22 out at the tip. The most critical region to get hit, show it this way, are panels 8, 9, and 10. They suffer the severest heating at the apex, meaning where it's most rounded at the top. And this is an example of reinforced carbon-carbon. It's, I think, still proprietary product, exactly how it's made. It's a woven and baked carbon material. The gray stuff is a coating called TEOS, T-E-O-S. I think it's an acronym for something. And there's a lot of chemistry that goes into this, and material science. I don't work in that area, but people like Dr. Don Curry, retired, worked his entire career on this stuff. And it's not really an insulator, it's a structure. It's the outer, it preserves the outer mold line and curvature for aerodynamic reasons of the outside of the orbit, but it suffers the most heating. Inside there are tiles and there's Inconel fittings that hold these panels in place. You're just seeing this is probably a test coupon. So an actual panel would be highly curved, and they come in sections. Like I said, 22 of them, panels 8, 9, and 10 we think are the regions where they got hit. It also turns out, as misfortune would have it, when you have popcorning from the tank, there's little pieces always popping off the size of popcorn. They're streaming in a flux, and guess where the aerodynamics funnel them? Right in here. And in Return to Flight, that strong recommendation of the CAE is that put on a wing impact detection system. We did. There was a network of accelerometers put on the left and right wings interior that would sense pinging any impacts. And they turn out to be quite sensitive, and they're so sensitive they sense many, many hits, but there's no damage. So it means that a lot of the debris that's falling off the tank, mostly foam, we really try to control ice now. The program's over, but we try to control ice by inspections during the tank fills, and sometimes we would not go until that ice was mitigated somehow. But foam in little pieces is always hitting this area the most. And every once in a while, even in Return to Flight, it would still be a large piece of foam. Two come to mind. One during the Hubble maintenance mission in 2008. A large chunk came off the tank. It's kind of surprised at the tank project, but it was a narrow miss, a near miss. Well, STS-114, the first Return to Flight, another chunk came off one of the ramps and narrowly, well, it missed the orbiter. And that's where Mr. Hale, who was shuttle program manager, said, I am mortified. He wrote an email to the crew saying, I'm mortified to tell you another piece came off and missed the orbiter. Never could control it. I think the tank did a remarkable job, admirable job of increasing the quality in the sprays, and they removed a protuberance air load ramp that we found was not needed. That was another potential source of large debris. Removed these bipods, did some other work, a lot more inspection, a lot more ice inspection. Despite that, you still get unexpected debris releases. I'll also tell you there's debris sources from other, there's debris that can be liberated from other sources, including the orbiter itself. Wire, baggies at the, where the feed lines or the, that come in from the tank into the orbiter. There's some stuff that can come out of there. They're rare. They tend to be singular instances, whereas foam tends to be more of an environment, a flux. Okay, so we got hit at panel 8 or 9 or 10. The San Antonio tests in July of 2003 pretty much showed that you can get a hole from this going about 500 miles an hour. But that alone wouldn't have proved it. You know that there was a lot of forensic evidence done studying the vehicle debris, the molten metal that appeared here and there that could have only have come from this area, from the left wing area, and it had splashed onto the Ohms pod, and the aerodynamics computed that there's a stream, a flow that would have carried it there, and it was found in that spot, the Inconel alloy of the molten stuff. Plus the sensor death. There was a huge reconstruction effort to show how the sensors were dying in clusters. The timeline for the sensors going offline and failing corresponds to the thermal analysis that was done in the study of the increasing damage on the wing. All that put together made a compelling story that it was a hole, that area. One of the reasons I believe, and I think the Cade pointed this out too, is that perhaps some of the opposition to doing anything about a potential hit or a possible hit is that the vehicle and crew and all the experiments were pretty much going smoothly, going swimmingly, I would say. Very minor problems going on during the mission. So one of the points I make here is that here's the mission aloft. The flight readiness process has already been done. We've already pointed out the risk. That process went very well. We pointed out all the things that had to be fixed or mitigated before launch. And engineering is expected to do that with its contractors. I signed a flight readiness statement. But when the mission's up there, though there's a blurry video from Flight Day 2 that's subject to interpretation. It says something hit, but we don't know where it hit. How bad it is unknown. That's subject to interpretation, speculation too. But there is no data at mission control on the screens. There's no sensor showing anything's out of whack. The engineering consoles say the same thing. There's nothing out of the ordinary. And the crew has reported nothing. And the vehicle is performing extremely well on orbit. So it boils down to, what does a blurry video mean? What does it mean? Well, it bothered the intercenter image team very much, and they're the first ones to have started attention on perhaps we should need extra data or a photo on this. Let's go to the next slide. In hindsight, this is just Newton's law written in a certain way, but this is one of those regrets that I have. I have many regrets from this mission about not following through and taking action all the way and informing upper management. I could have done this with a paper and pencil and a calculator, but I'm just pointing out here, I guess more for my engineering audiences, that you can show, the bottom line is, if you take estimates of using the foam, what we knew of the size, the density, the relative speed, because we had those parameters during the mission. We had those. Our aerodynamicists on our debris assessment team, and we had Michoud representatives, we had safety, we had pretty much all the stuff you plug into this equation. You get thousands of pounds. Other people have done that too. It just says that whatever it hit is going to suffer a huge force. And if it turns out to be a brittle, thin panel like this, it will break. Nothing can sustain itself against that kind of hit. Something's going to break. Now, if it had been tile acreage, maybe we would have just blasted a crater open, the aluminum skin would have survived, but certainly not a carbon panel. Now, didn't know it was a carbon panel, but it was one of the three possibilities from the blurry video. It was just an open question. Did it hit the carbon panel? Did it hit tile acreage? Or did it hit the main gear door on the edge? If you hit the main gear door, there's some tiles that have no metal underneath. They're kind of overhanging like this. So they're not supported. So if something hit them, they'll just snap. And there's a thermal or ropey seal that prevents hot gas entry into the cavity. If that broke and that was fixed and returned to flight, that area was identified as a very vulnerable area because the tiles are thin. If hot gas entry goes in there, the tires will overheat and they become potential bombs. They can explode. You know, they're inflated to about 400 to 500 psi. 10 times more than your car tires. Anyway, next slide. It just says, you do the calculation, something's going to break. Debris assessment team, I tend to call this the DAT or the DAT. Not all my audiences are familiar with that term, but Flight Day 6, United Space Alliance and Boeing had formed this, and they were obliged to do it. There was some kind of process to say if something extraordinary happened, it was called out of family. We use those terms at the back of the presentation. We had these two categories of damage or events that could occur, problems with the orbiter. They're in family or out of family. In family kind of meant that we've seen this before, it's clustered together statistically, there is capability in the vehicle, and it's not a big deal. Out of family meant none of those things. We may need extra help. NASA may have to put more people on it. And I'll remind you, in those days, in 2003, starting in the 90s, we were on that road to privatization of the shuttle. So United Space Alliance and Boeing were to one day have total control of running the orbiter and the space shuttle like an airliner. And we were supposed to gear up all of our NASA subsystem managers that were overseeing either structures or this or that, whatever the particular systems were in the orbiter, they were to let go of that and not working on it anymore. We were to work on future programs, inflatables, X-38, other advanced projects, and so on and so on, exploration, so on. Some of our engineers refused to sign those transition papers. They said, no, you're asking for trouble. The orbiter is always an experimental vehicle. The CABE reiterated that in their report. You always get things you don't understand. It's exceedingly complicated, very hard to sometimes understand its complex environments and the things you see. Well, yeah, nevertheless, we were proceeding to privatization. So the United Space Alliance and Boeing were responsible for getting this team together. I was division chief engineer for orbiter in my department. I still am in the structural engineering division at Johnson Space Center. But my job then was to do, I can't distinguish between the words, either oversight or insight, surveillance of what the contractor's doing. But our department, our engineering division, oversaw tiles. This is a test tile. This is not from Columbia. It's from a laboratory, but I've been using this in public talks for many years. It's in a Ziploc bag because the particles can get in your eyes. It's not really for handling. I'm going to pass that around. Just be careful. It will break if you smash it on the table. You can see the black coating. That's glass sprayed on. The white is a ceramic made from silicon oxide. And on the bottom, the white side is where the glue or the bonding is put on the orbit. But our department handles tiles, the carbon panel, all the insulation, blankets, the main gear, the drag parachutes, the structures, structural testing, structural analysis, dynamic testing in terms of vibration, material science, fracture mechanics, thermal analysis, windows, know I'm leaving out a whole bunch there, but our contractors would have a subsystem manager for all those areas. I had to sweep and survey all of them at this depth, this much, and say we were ready to go. They would write reports about problems they were encountering and preparing the orbiter for flight. So I had to use all my time just surveying all of those areas, and they were okay for flight. We would report to the engineering director in a what we call an engineering pre-flight readiness. A strange, odd thing happened though by Columbia. We didn't have an engineering pre-flight readiness for Columbia's flight. It had gotten to the point of just write an email. If there's a problem, just bulletize it in an email and just send it to the director. We didn't even meet formally. Even though in 2002, the year before the accident, there were major, major problems with happening with Orbiter. Cracked flow liners, propulsion. There was damage to the robotic arm because a platform hit it. There were other mysterious things going on.
Vistra balls.
The Vistra, the ball strut tie rod assemblies, they were cracking. There was the aft spherical joint, the joints back here that connect to the tank. It's kind of like the hip joint in there, like the femur joint and hip joint. Those were cracking. We didn't know why. There were dents in there. This stuff was piling up in 2002. We were grounded by the flow liners for months. That's why 107, instead of going early in 2002, it went into 2003. It was delayed almost a year in flight because of these problems. Despite that, the engineering director, Jed Johnson, just quit having a flight readiness. We had talked about those other things, of course. So anyway, the debris assessment is formed. The debris assessment team is formed, but immediately questions like this were the Tuesday following that Monday holiday. These questions came up. Is this in family, out of family? Does it make a difference what it is? We think it's out of family because there's a lot of concern from the image people themselves, Kennedy and Marshall, that they're worried this is the worst they've ever seen. What does that mean? Who owns this? That was not really a question at the time, but it was later. Like, I know we're supposed to report to the mission manager of the MER, that's our engineering side that's next door to mission control. We see the same data as mission control does. And then we're supposed to talk to the mission management team. And we only have 3 days. But it's not clear what the process is to report things. See, if mission control or the crew of this MER had seen data that said there is a problem, they form Tiger teams. They start assigning. Things happen quickly. You're on the Tiger team, da-da-da-da-da, and you have this amount of time to work it. Maybe it's incrementally or whatever. But because it was not, this kind of formed on its own on the side. And it wasn't clear how we were to be supported if we needed extra data. That came up. So the discussion, we were running those blurry videos at the meeting in our conference room over and over and speculating where it hit and what do we need. And it was clear, even though we had the right technical folks on there, we had the Boeing thermal analysts, the right aerodynamicists, we had people from the chute online that were telling us about the density and nature of this foam. There were safety people there. There were like 33 people, some on telecon and some in person in the room. They said, we can't even start an analysis. How do you start one? How can you initialize it? We don't even know where it hit. What's the nature of the damage? Otherwise, we're just kind of making this up. We need more data. So it was clear that we needed a photo or an image, an extra one, something clearly showing the damage. Where and how bad is it? It was unanimous, and I volunteered. I said, I'll do it, but I'm going to do it the engineering way. I want our engineering management to know. We're going to go to the engineering director, and he or she would go to shuttle program management. We need to coordinate all this. That started that email that's in the back of your pitch, where I, since it was so extraordinary, I used some pretty strong language. I said, can we ask or beg for such a photo? And I put people CC'd on there. I wanted the language itself to capture attention, that this was so unusual and outside the box that it would surely trip some action, including, why are you writing such a strong email? Like, come in here and talk with me. amazingly, nobody did. It was just, what was strange about this whole thing is the loud silence of no interaction or attention from any level of management, no level of management. I'll tell you more about that.
May I ask a question?
Yes.
Just to make sure I'm understanding correctly.
Okay.
You're saying that through the whole situation after the phone came off, it was never officially, there was no official action to investigate this. This came from ground level up, that some people thought that there was an issue and that was part of the problem?
Well, the
Can you
official...
repeat the question?
Oh.
I can hear on the line.
We're
Yeah.
turning the mic on now.
I'm sorry about that. My question was to clarify whether or not the issue was that at the higher level there was no recognition that this was a potential issue, that the foam had come off, so there was no official action, and that this all came up from the ground level troops who had some concern about it.
Well, let me answer it this way. The official group that was to answer this question was the debris assessment team. They were given the specific action and a date to report. Meanwhile, which I didn't know about all the other activities and communications going on in the background among shuttle program itself, with Wayne Hale, the Inter-Center Working Group person, Mr. Robert Page, and others. There were things going on there I had no knowledge of until afterwards. I read the report myself. Those are well documented in Chapter 6 of the Cave report. So there, in the background, are other people asking for photos, like Mr. Hale. Let me see.
So who gave your group the action? Was it Wayne Hale, or was it the
that's
mission
part of
management team? Or
it's USA Boeing forming this team. I wasn't asking at the time what individual formed the team. It looked like it was a USA Boeing function to just establish a team for an out-of-family situation. We weren't even asking that at the time. We knew we had to report to the mission evaluation room and to the MMT later. So we thought, well, that's the ownership there. But because the MER was not active in forming a Tiger team, I thought I better coordinate engineering management, and then we'll approach shuttle management.
So was there a chit written? I mean, if there's a
No.
chit written, then things are going to happen.
One of my regrets that it's a page I'm going to put in here at some time. I regret, and we had 33 of us to think of the same thing, and we all failed, is if you write a chit,
what's a chit?
it's a request for an action, for data or action. I want something done. It might even go to the crew. But it initiates a process formally, and it gets reviewed. At any point it can be shot down, say no, denied, or it'll go on to the next level. It goes up higher and higher. At least it would have officially put down on paper and on a trail a documented request, and there would be no fuzz or equivocation about who's asking for what. If you read Chapter 6, you'll read about shuttle managers saying, I don't know who's asking, even though there were people asking. I don't know who's making this a requirement. I've heard that this person's asking, but is there a requirement? And one of the things that in our very first meeting of the debris assessment team, is there a requirement for a photo? That stymied us because I thought only control boards can make requirements. Only programs and projects can make a requirement. That's a very formal, lengthy process, and hammering out the words. How can an assessment group make a requirement? But the shuttle program managers were using that word. Who's making this a requirement? That scared us. Like, we didn't know how to respond to that word. But nevertheless, we knew we wanted something, and I wrote that email, and things started happening where I started approaching people within engineering and also the Orbiter project and getting some pushback and some hot opposition to the request. But we were under the gun. How do you get the answer in 3 days without any more data? We got to get something fast. We got to get something fast. I went down the hallway. The very first thing when I heard about this video, and it was a phone call I got, was, well, how bad is this? I had no prior judgment, or I had no judgment whatsoever. You got to. So I asked our experts for tile and carbon panels. How bad can this be? And they said it can be pretty bad. I said, well, how bad? Is it loss of the vehicle? That's all I needed to hear. If the experts there, the resident experts in those thermal protection systems were worried, then I was going to be worried for them. Okay, now I got the ball. Now we're going to, and the debris assessment team met later. That was after the holiday weekend. We need a photo. I'm on the road to do that. I wrote the email, and then later I was to learn that the MER had the MER, according to their logbook, says no photo required. And we thought that was a direct answer to us. It turns out there was a lot of confusion happening during this mission. That wasn't necessarily a no to us. They were just saying they were not interested. But it turns out, unbeknownst to me, there were many other people asking, including the head of SCNI, Mr. Lambert Austin, Shuttle Engineering and Integration Office. He had put out at the behest of shuttle program managers like Ms. Linda Ham and Ron Dittemore, can we assume that there's no safety of flight issue because this is not dense enough to cause damage? We responded back. They went out to a lot of engineers, including me, aerodynamicists, and said, no, you cannot assume that. You cannot assume that. In fact, here I listed some dangers, responded back to Mr. Austin, and he filed a photo request. Mr. Hale filed, I think, the very first one. And they were all turned off by upper management. Basically, they were saying, what are you doing? Mr. Hale was authorized to do so, but he was talked out of it. And he wrote a very moving email on that to all of us. He said to well, I won't quote it here, but it's very moving. He's full of remorse when he wrote that. Mr. Austin filed it, but he was not necessarily authorized to do it. But once, he was forced to turn it off. It was turned off. There were others begging from the Intercenter working group, talking to Wayne Hale, please, you've got to do something here. And there were other people that I know of that were also asking in their own way. I seem to get the real hot opposition. Next slide, please, and I'll talk more.
Someone's got an open mic. Please check your mute buttons.
Okay, I think next slide.
Sorry about that.
Thank you. Well, okay, I mentioned there were several people asking, but I didn't know all about that at the time. All I knew was I'm representing this group and I'm asking. But by the time we got this quizzical or enigmatic email saying the MER is not interested or not pursuing a photo, we all interpreted that as that means no, and we're saying no to you and your group. Well, we were thrown into consternation. Why are they doing this? We had rumors like maybe they've already taken a photo and they already know. So now we can stand down. Are they going to tell us? Are they going to tell us and call us into a room? No, that never happened. So I also got into a phone conversation. It was pretty heated with our engineering integration office about this. I need to see the engineering director. I need you to facilitate it. We all need to talk. And he's basically told me, no, I'm not going to be chicken little about this. It's in chapter 6. And you don't have any evidence it's that bad. I got very angry. I was furious. And I said, well, shuttle program is acting like, he mentioned a bird, Chicken Little. I said it's acting like an ostrich with its head in the sand. And my coworker was laughing because I said that. And to diffuse the anger, somebody on the other end said, well, at least they're both birds. And trying to get us the emotionality down. And we felt hobbled. Said, we've got to cobble together an analysis somehow with the tools we have. How is it going to be meaningful? So it brings up things like, if everyone, those in upper management are saying no, do your best, make reasonable assumptions, so on, but I'm really not, they're also implying, maybe not directly, I'm not going to give you more data. Just do the best you can, but give us the answer. Is your job finished? I don't know the answers to these for everybody. I know in my case, I regret not breaking the door down, not getting all, gathering all the support that I think we needed to go up to the highest levels. I deeply regret, and I told Mrs. Husband this, I wish I would have broken the door down. And it turns out no level at engineering management, even in my own division office, would support me. Some of them were out. It was late in the day when we think we got the no on the request. I found one manager, my own supervisor, that was supportive. But if you went up any higher, they all fell into what I call a form of prove it's unsafe. And it's, the mission is going well. You have an extraordinary assertion that this could be catastrophic. It turns out, in hindsight, I can see that it's one of these problems that's got weak evidence behind it. It's subject to what you think it might be. The outcome could be very bad, horrible, catastrophic, but it might not. And I can't prove it either way. With the meager data I have, in this case a blurry photo, I can't tell you which edge it's going to fall on, what outcome. Very, very bad, kind of bad, or okay. Are we going to make it back? We need extra data.
How much of that was conditioned by foam coming off the tank as just a maintenance issue? Did you hear that from the team?
I can't read chapter 6 and the previous chapters about the whole history, about how the mindset and philosophy of the shuttle program. I didn't develop that story, but the cave did. But the pre-staging of thought to arrive at the Columbia scenario. I can tell you that there were, in my personal experience, there were two other things that happened before the launch of Columbia that I think fall into the prove it's unsafe. One is that we launched the solid rocket booster. I was called at 10:30 at night, just before the tanking, for a last-minute issue. Our factor of safety is 1.4 on all shuttle systems. We have to cover uncertainties and overload protection. It had dropped to 1.18. Marshall engineers were coming in and said, we did some tests. There's the struts. There's if you look at the solid rocket, it's got a ring around it at the base, and that connects the struts to the tank. It's plummeted. We've done some material testing called toughness tests. It's correlated to ultimate tensile allowable. The allowable is supposed to be 187,000 pounds per square inch. It's down to 156 from our testing. What? Later, in the weeks to come and return to flight, it was to plummet even further. They were doing spot checks, and it was highly variable. It was an improper heat treat when they delivered. The stuff was manufactured, delivered. It did not have the uniform material properties, the strength. Major structure that holds the booster to the tank. But a waiver was issued. I was called in as representing the loads panel, but I didn't have time to get the forum together, and that's another one of my regrets that I point out. If you're called in as lead of a technical panel or group and you're by yourself, you're not the group. You're one member of the group, but you're not the group. You don't have all of the expertise that they all can bring to it, to all the questions. But the program kind of saw it. If you're the chair, then you're representing the group. But here's the problem, right off the shelf. We pointed out to the MMT, this is off the shelf. There's a lot of uncertainty here. They have the prerogative to accept the waiver. We tried to get out of it with special analysis, couldn't do it. Couldn't restore the factor of safety. So they accepted the risk. The other was, we were pointing out the cracked duty bones, that if they were aligned right, and it had a deep enough crack, it could crack in half. You lose support of a feed line inside the orbiter. There's an octopus of feed lines in here that are feeding the tank. If that came loose, if that joint failed, you'd have this line just waggling and vibrating violently all over the place, and it could rupture and blow up. We did that on L-1 on Columbia. The attitude at the table then is, how dare you come in here with a late analysis like that? This is inappropriate. We're in a countdown. This has no maturity behind it. This is for an engineering study. To me, it's prove it's unsafe. We're there to tell you a problem. I had my Boeing subsystem manager, who was highly regarded in his area of loads and dynamics and stress for the orbiter. That was his job. We went over this thoroughly before we presented it to the orbiter project, and yet said inappropriate to bring in like that. What I would have wanted, we were chewed out pretty well, was, wow, that sounds pretty serious. We'll probably have to investigate this more and maybe do some testing on that very area. You're telling me it's a smart alignment of the ball, so that makes it low probability that, you know, the ball has to be, with it cracked, has to line up perfectly before I have that kind of scenario you're talking about. We're going to look at this afterwards. Thank you for telling me, but I'm going to proceed with the launch. But we've talked about it, and that's all engineers want, is that you're informed of the risk. If you're a manager, you're going to make a decision, and that's what Brian O'Connor told us when in front of Mr. Scalise. We accept risk as managers. That's our prerogative. But I need engineering to tell me what all the risk is, all the details. Tell me what it is, and then we'll decide. But I think what I saw happening here is I've heard enough at that time. I've heard enough. I can make a decision, or again, I think it's some forms of the prove it's unsafe do come up once in a while. They even come up today, but sometimes they're nipped in the bud. I've heard Mr. Bill MacArthur, the last orbiter project manager, former astronaut, there was something else on orbiter acoustics happening, and somebody said, well, why don't we launch? Why do you need rationale for that flight, that flight? If you got rationale for one flight, why don't you have them to the end of the program? He said, no, that's prove it's unsafe. We need to measure this anomaly. It was excessively, I don't know if you know this, but every once in a while, in the last shuttle flights, the last few, the engines were getting louder and louder, exceeding their data book value. And we were worried about cracks and overloading the aft end of the structure. It would only happen every once in a while. It wasn't every flight. But we had put on extra measurements. And we said, no, I need to learn flight by flight what's going on here. I will not get into the prove it's unsafe. Went, wow, actually got it. Next slide, please. One of my regrets, I reviewed what Boeing and USA put together. They used tools, Crater program, infamously detailed in Chapter 6 of the Cave, an ICE program, and TPS seal disruption was kind of made up. It was an ad hoc analysis. It was questioned. Some of our engineers on that did say, are we sure about this? In hindsight, even though if you read it, and it was torn apart by PowerPoint experts, if you read it, you will see highly uncertain. Use of this tool is way outside of its test data bounds. We are very uncertain about the damage, where it is, and the application of this tool. It doesn't, and it does say, but if you analyze it this way, it's what we should have said is, here's a representative case based on reasonable engineering judgment. A representative case. We show no safety of flight issue in this case. Here's what we fail to say. But we can't tell you that the real damage is actually like this. What's really on Columbia, does it resemble in any way this representative case? We cannot tell you without extra data. We should have said that. We should have collected all that uncertainty on the first page, in my opinion, and stated that very boldly. You're going to hear of a representative case with no safety flight issue. But I can't tell you it's the case. But it went further. This wording here got picked up and repeated. No safety flight issue then. By that time, we in the audience felt pretty much beat down. I had already gone through my 7 attempts I documented 7 attempts at trying to get a photo in various ways. One was getting the crew to look out the window, and is there a chip? The Cape calls that missed opportunity number 1 in Chapter 6. The 2 arguments I had very heated with engineers. One in the Orbiter Project Office, a tile expert, but not a dynamics expert, not an impact expert, not a carbon panel expert, a tile expert, who was telling the program everything's fine. And it didn't work in our DAT, but I brought him into the DAT later. After I had a really heated argument. The same person also said, after he heard me, my voice must have been very elevated about all the possible scenarios and burn-throughs. Told me back, well, and he put his finger in my face, and he said, if it's that bad, there's not a damn thing we can do about it. I was just so taken aback with that. But that phrase in another form was used again by other people. If it's that bad, there's really nothing we can do, right? Mr. Hale was told that. If you read a book called ComCheck, Final Flight of Shuttle Columbia, I interviewed for that book, and there's first-hand accounts. So it's people actually, in their own words, are in the book. Mr. Hale's account is in there in his own words. He was being told there's no repair kit, there's no EVA procedure. We don't get very good pictures from these military pictures or DOD. That doing a special EVA is dangerous in itself. The mission is going so well, we're going to interrupt 1 or 2 days just to realign the orbiter, get the lighting right, and get the right photo. And you don't learn much about it anyway. Therefore, you kind of have to hope it hangs together, right? So I call that a form of proof it's unsafe. Okay.
Well, to be fair, we don't know. I mean, I do think that, or do you agree that while the process to identify whether or not there really was a problem or the magnitude of the problem, that process really failed, right? We don't know if there would have been a way to save Columbia or repair it if we had found this out. So, so some of that is true, actually.
I'll agree that
the attitude is wrong, but the
I'll agree that there would have been extraordinary work to get ready to do it, and it would have been disrupting the mission. Yes, it would be up to, as long as we could air out all those details and debate it and point out what we can and cannot do. It might have become an Apollo 13 type scenario.
Right.
And I point that out later. That's one of the losses, in my view, of not doing anything here, is that we didn't get hundreds more or thousands more to put their creative thinking into this problem. And I'm including Russia, too, what they might have done with the Soyuz, I don't know. Mm-hmm. But there could have been many, many things. But I'll also admit, I'm often asked, sometimes asked, even if you try to repair, could you have saved the crew of the vehicle? We don't know. We don't know. It might have been doomed anyway.
Right.
However, I asked Anthony Antonielli, astronaut, at a meeting at Michoud, if the ground told you there's nothing we can do, it's been assessed by engineers and whatever, analysis was done or testing, there's no safe entry, you're doomed. What are you going to do? He said, at that point, we're in charge. I don't listen to the ground anymore. Mm-hmm. Just, we're going to figure something out. We're going to try whatever we can. I said, Tony, that's exactly what I thought you'd say. Mm-hmm. That now you're in charge, no matter what the ground says. I don't know the outcome. Yeah. Yes, it wouldn't have been trivial to spin up to have taken this extra data. Yes, ma'am.
Well, I'm in agreement that if we had taken some measures and given, the crew had the ability to stay on orbit longer, so that perhaps if you had engaged more creative minds, that something could have come up with. And I think there's some merit to the astronauts knowing what their fate will be and having the opportunity to make their peace with it and say goodbye to their families and things like that. And from a purely, NASA asset point of view, that's a little harsh in the circumstances, I think more of the science data would have been saved too. Because I know the project manager for the SOLS 2 instrument, and they lost the vast majority of their data because the telemetry only allowed them to download a small fraction of the data while on orbit, and most of it was being written to a hard drive, which was lost. So I think that there's a lot of merit in having just taken some more time if we had been able to do that from so many different levels.
I'll get one of the experts, the expert, who retired, Dr. Don Curry. said, worked on this his entire career. He came up with ideas. I don't know if they worked. He said he would have had the crew freeze water bags, take all their clothing, do the EVA,
Tools
stuff
in
the
there.
whole, not to prevent the wing damage. He said that's inevitable, the hot gas entry. But to delay peak heating is a brief period of time in terms of seconds. Then it comes down off the hump with peak heating. You're still going to get hot gas ingestion, but it might have delayed that long enough where you have a warped wing and you're still somewhat flyable, and you make it to the ground or bail out down to the ground. We don't know. But he was not one of those dealers. Let's go to the second slide. Here's some contributing factors. And I've already said that we don't know what would have happened had we even pursued a photo. But confusing ownership of the issue. Sent emails. I'm part of that too. No reply. I tried to be very clear in my wording. I somehow sensed that these emails that I wrote would be read later. I tried to write them so that a new person reading it would go, oh, well, I guess I understand what this is about. Nevertheless, there were other people writing emails that have equivocal language, kind of hint, something's going on. One of my engineers for the landing gear, and I was worried about hitting a door seal and all that. He was writing his colleagues up at the impact laboratory at Langley. It made it to the center director at Langley, you heard. It made it back from there, back down to the landing gear expert in MOD. And there's this email trail, but they go up to Brian O'Connor. My colleague is a friend of Brian O'Connor. Hey, there's this analysis, and there's this scary scenario of a wing stride. It could penetrate the gear, but it doesn't say, Brian, do something. We don't agree with it. It just says, for your information, this is going on. And later, he said, I didn't know what to do with that email. You're not asking me to do anything. So how you write an email and what you want, I think, is very critical. What is it that you want in there? It was not clear from my colleague. Confusing emails. Lack of clear processes. We brought up the chip. We were told this, my boss and others, don't ever email managers in high positions. All that is always coordinated. I always went, well, then why are they in the address book? But in return to flight, I went ahead and emailed Sean O'Keefe. Because one time I was just reading, he was talking to CNN reporters. Why didn't my engineer say something or complain? So I wrote back, Mr. O'Keefe, why don't you ask us? Why don't you ask us instead of just saying that in front of reporters? He sent somebody down to talk to me. He sent one of his assistants to come in. We had a really good talk. He wrote everything down and reported back to Mr. O'Keefe, and Mr. O'Keefe wrote me back. Said, thank you, I think I understand now. Large uncertainty, we didn't present that in that flawed analysis. The CAVE even pointed this out. I was always wondering why, if engineers, even the experts on this big team, were saying there might be a problem, we're very concerned, why aren't they asking more about this? Why aren't they saying, even I could have accepted this. You're writing some really strong emails. I don't like how you're doing that. Come into my office and we're going to talk about it. You know, what the hell's going on here? There was none of that. It's kind of like you're left alone to work this. Integration that flows only one way. Afterwards, we had communication meetings, team frame meetings within engineering at Johnson Space Center. One of the engineering integrators said, well, my attitude, or I thought my function is to integrate downward. We're given the funding to engineering to do analysis, assessment, labs. I integrate down, I don't integrate up. And I had a big argument with him. That was one of the people that had a heated argument. 5 minutes. I'm going to go ahead and ask for questions because we're such near the... I have other things like emotionality. I have contributing factors. I'll go ahead and mention that one. Two of these people admitted, the reason I didn't do anything with you, Rodney, is you were so angry. But I worked my way. I mean, I didn't start angry. I escalated to that. And the point is, I don't like dealing with angry people either. I don't. But if you need to back off, why not ask somebody else to handle it, tell your supervisor, but don't drop the issue. What happened is, I'm going to quit talking to you, but I don't even remember what you were talking about. The issue just goes down the crack. Another recommendation is don't go alone. You become the messenger, and your face and name become associated with the issue or concern. Take your team with you. And I found that work later in another project. I'm going to pause for questions. Yes, ma'am.
I'm struck by your remark that people were like, well, I didn't want to deal with you because you were so angry. And in my experience managing teams at NASA, the only time engineers get mad is when they're scared. They usually don't even themselves understand that they're scared, because they're scared for the hardware, and they're not like scared that they're going to be personally injured, but they're scared for the project or for the hardware. And the only time I've actually seen engineers yelling at each other or screaming at each other or just getting ripped hot around the collar is when they're concerned about the hardware. And I've
That's
taken
behind
that
it.
out of, as I've progressed through my career and sort of left behind the engineering floor and progressed into management, I've really taken that to heart. That if I have someone in my office who's angry, I have to sort of like get past the emotionality of wanting to respond to that anger, and then ask myself, why is this person angry? What are they afraid of? And I think that's maybe...
And you're curious about it.
Right. And
why is this happening?
I have to solve this problem, because I'm still an engineer at heart. I have to solve a problem. But I think that, what you say, I really take that to heart as another example beyond my own experience in the field of, if an engineer is angry, it's because they're scared, and they think it's important, because they don't get angry about little stuff. And in hindsight, I have to say, I'm especially distressed that somebody chose to not deal with you because they were angry, because that should have been the indicator of how important the issue was.
Thank
You
you.
would probably have to wrap up here and take a heat from the
Please
hallway
read
there.
please read the improvements. I didn't come here just to be negative. In your package, you'll see the improvements we made. The question is, do they get passed on to the new projects and programs? Do they get communicated? We have conferences now. I'm going to one, and I've been to several. We're collecting lessons learned. We're always worried about, we're the choir. We know it. We would implement it, but will new managers implement this stuff? We don't know. We feel it needs not just captured, but required reading.